Okay, so I'm back, and what we're doing is it's probably a good time. I mean, in the schedule, I have us actually doing this over 2 lectures. So this is again 10.2, and we're doing 1E, and we were getting ready to graph the equation x plus y is equal to 0. And I just gave reasons for you to accept that you can do this by choosing any value of x you want, and you're able to find a corresponding value of y. Or similarly, you can choose any value of y you want, and you can find the corresponding value of x. So we have choices. And whenever a mathematician is given a choice, we go hog wild with it. We go crazy. We choose the easiest things that we can. So sometimes that choice, the easiest thing, won't always work. But in this case, and in most cases, it will. So in this case, let's just do the following. Let's just choose a value of x is equal to 0 and a value of x is equal to 3. I kind of like to space points out because you're going to be plotting them, and you want them to be a little bit distant from each other. It makes it easier to plot. So remember, this corresponds to, I'm giving you a value of 0, find the value of y. Down here, this corresponds to what we were doing earlier. I'm giving you the value of 3, find the corresponding value of y. And if you want, you can actually do another point. But we only need 2, so if our algebra is really good, we'll be done with 2. So in this case, x is equal to 0. So solving for y, I get y is equal to 0. So it goes through the origin. So my corresponding value of y is 0, or my corresponding ordered pair is 0, 0. Because I just discovered y is equal to 0. So now again, let's start all over, and let's let x be equal to 3. And I know a lot of you can do this and you've already done it in your head. It's fine, you can fast forward. So 3 plus y is equal to 0. So I'm solving for y, so I'm going to take my 3, I'm going to move it to the other side. So that gives me y is equal to 0 minus 3, which is y is equal to minus 3. So I have minus 3. So my corresponding value of y over here turns out to be minus 3. So I have two values. I have 0 and 0, and 3 and minus 3. So let's plot those. So 0, 0 is the easiest one. And 3 and, so x is 3, y is minus 3. Here's my other point. And I'm going to let the computer draw my line for me. What you will be doing is you'll put those 2 points down, and then you'll either freehand draw a line between them, or I actually have a cheap ruler if you got. I always like to use a ruler or a straight edge. And that is indeed what the line looks like. It goes through the origin, and it intersects the point 3 minus 3. Okay, so you saw how easy that was when I chose x to be equal to 0. Well, maybe I can double down on that. Let's double down on that choice. Now sometimes we're not always able to make this choice. Decrease that a bit. Let's do y, maybe make it 1 bigger, y, maybe 2 bigger, is equal to minus 2x minus 1. So we're going to make a table of values. And I tell all of my students, we get to choose the values. I have to find the values of at least 2 points x, y. But I get to choose my x and I get to choose my y. So when I choose an x, I have to find y. And if I choose a y, I have to find x. So let's always make is x 0 once and y is 0 once. So see this kitty corner 0 format? That's what we're going to do. When this works, it doesn't always work, but when it works, it's the easiest way to use a table of values. This is called a table of value method. Make sure that's clear to you. To plot y is equal to minus 2x minus 1. And you'll be using tables of values all the time. So let's look at the first row. My x is equal to 0. So that's y is equal to minus 2. X is literally 0 minus 1. So y is equal to minus 2 times 0 is 0 minus 1. So y is equal to minus 1. So that's a minus 1. Not so bad. Pretty easy when we get to exploit those choices. And the next one, y is equal to 0. So y is equal to 0 is equal to minus 2x minus 1. So I'm solving for, in this case, I've been given x is equal to 0, y is equal to 0. I have to find the value of x. So I'm solving for x. So I'm going to move my minus 1 to the other side, and it becomes plus 1. And now I want to find out what positive x is. I know what minus 2x is. So I divide both sides by minus 2, minus 2. So I get minus 1/2 is equal to x. Now, unfortunately, we paid a price for making it easy. When you're given not a computer, but when you're finding a graph, you have to find where there's not a line for a minus 1/2. You have to find it. So over here, I have 2 points and they're really close together. And it's minus 1/2 and 0. So 0, and when x is 0 and y is minus 1, it's right there. But now x is equal to minus 1/2. You got to kind of figure out where minus 1/2 is. So you're going to have 2 points that are really close together. But for the computer to do this, it's not a problem. Let's actually see what that is, and I'll show you a way out of the dilemma. Because with the computer, you can literally zoom in as much as you want. So my first point was 0 minus 1. So here is 0. And right down here is minus 1. And then my next point is minus 1/2. and 0. So x is minus 1/2. I can change the scale until I get a minus 1/2 and 0. And now all I have to do is just zoom out and draw a line. And when I zoom way out, you can see what it would look like. But of course, that's with the computer. It may be easier to choose yet one more value of x or y. So let's do this. You decided, oh, they're too close together. I want another point. That's okay, you can do it. You can choose as many points as you want. So let's choose another value of x to be minus 5. With that in mind, let's go back. So literally, when you're given choices in math, you kind of use your brain to make them work for you. So I want another point. So first, I just want to remind you that of the points I just found. I just found the point 0, minus 1, and minus 1/2, and 0. Both of those points lie on the line. I want something with the x value larger, separated out. So I'm going to try minus 5, so I have to find the corresponding value of y. So y is equal to minus 2 times minus 5 minus 1. So that gives me y is equal to minus 2 times minus 5 is 10 minus 1. So y is going to be equal to 9. So when x is equal to minus 5, y is equal to 9. And it won't be difficult to plot 0 and minus 1 and minus 5 and 9. This one's a little bit more difficult for two reasons. They're really close together, and you have this value of an x coordinate that is a fractional value. And it's always nice to have integer values. And sometimes you just trial and error, right? Till you get good, and that's not what I need. There we go. So we've got one other thing. Oh, let's look at this one. X minus 2 is equal to 0. Well, that one's not going to be hard, is it? I hope you already see what's going on here. So this is, again, question 1G. And we're given the equation x minus 2 is equal to 0. We note no y variable appears. So that means let's solve for x. So x, let's add 2 to each side. And that gives me x is equal to 2. But we learned if x is equal to some constant c, then the graph is going to be a graph of a vertical line. So this is the graph of a vertical line. But you're still supposed to make a table. So let's make a table. The values x and values y. Whatever I write in there, x has to be equal to 2. So I have to write 2 in the x column. So I can write anything I want in for y. I can write y is equal to minus 2 and y is equal to plus 2. Anything at all. So that means I have 2 points, 2 and minus 2, 2 and 2, And these points are going to lie on the line. That would be 2 and minus 2, for example. This would be 2 and plus 2. But let's go ahead and graph them so you will believe me. So we have 2 and minus 2. So let's do 2 and minus 2. I've got the point up here. So here's my 2. Here's my minus 2. And the other one I chose was 2 and plus 2. And it's right there. And when I draw my ruler between the 2 points, I get a vertical line. So one last reading problem, and we're done with part 2. So back to here. Here is an applied problem. Now I know you're actually watching this video because of COVID-19. In COVID-19, we graph, if you've been looking at the graphs, it exhibits exponential growth. But many things don't exhibit exponential growth. They exhibit linear growth. And this is one of them. So we're given a formula that I started the wrong program. This is the program I actually use in other classes to produce worksheets that look really nice. The worksheets that we use for your class are actually done for me because it's an awful lot of work on my part to produce those worksheets. And in your class, thankfully, we have some good ones already done. So let's look at this one. The value of a house. So Y stands for the value in dollars of a house. And X in this case is going to stand for years after purchase. So X equals 0 is the time you purchased it. X equals 1 is 1 year after that. So we have a formula that tells us that Y is equal to 7,500X plus 120,000. So that means the value of your house is equal to 7,500X, where X stands for the years after purchase, plus 12,000. And Y is the value of a house in dollars. So they want us to given that X is equal to 5, find the corresponding value of Y. So that's going to correspond to, after 5 years, how much is your home worth? So Y is equal to $7,500 times 5 plus $120,000. And that's equal to $157,000, $157,500. You all can do the math on your own. So that means that your house accrued in value quite a bit. That in 5 years, that's the reason people like to invest in real estate, if this is indeed true, and that real estate continues to go up in a linear fashion, that means you just gained in value of your house $27,500. That's a large percent increase. But of course, that's assuming that this equation is accurate. So that was the first thing. And the second thing we're asked to do, so the ordered pair solution, let's complete this out, turns out to be, I'll have to give myself some more space here. $157,500. So that's the ordered pair. So the next thing they're asking us to do is to write a sentence explaining the meaning of the ordered pair found in part B, which is labeled here as H. Well, we already did that. So let's do it formally. The ordered pair 5, 157,500. So remember, this comma separates my x value from my y value. The comma over here separates the thousands from the hundreds. So x represents 5 years after purchase, and y stands for value of house after 5 years. So that represents linear growth. Let's actually see what that would look like. Let's go to GeoGebra really fast, and I'm going to put in this equation so you can see what is going on. Because a lot of people really care about math because of finances or monetary things. So we're going to graph y is equal to 7,500 times x plus 1,000, was it 120,000. And what is it doing there? I have to go way out to see it. There should be a line somewhere. Let me erase all of these. If you're bored, the lecture's over. But let's do it all over again. So y is equal to 7,500 x plus 120,000. No line. Maybe I should just do, I don't know why it's not working. It's not, I'm not going to mess with it, but it's basically a picture of, again, I hit the wrong thing, the command line for Linux. It's basically going to be a picture of linear growth. So I'll just sketch that out for you. So we're going to have, it's an example of when our axes change. We're just going to look at the first quadrant. This is still going to be my origin right here, but I'm just going to draw the positive values. So x is going to stand for years, and y is going to stand for house value. And this point right here is going to correspond to 0, $120,000. And as time goes on, trying to draw a straight line up, we see that the line is increasing, so the interpretation is as x gets larger, as time progresses, house values increase. So think about this. Math could allow us to see into the future, and we make predictions all the time. So assuming that that equation holds, I can calculate the value of my house in a certain amount of time. At any rate, that's all of the lecture for today. I'm going to post these in two different parts, part 1 and part 2. And welcome to the world of graphing and 2 dimensions.